Thank you. Thank you, everybody. And let's speak about Wi-Fi, phishing, and red teaming. So, usual introduction, you can just see it later on the slides. It's not important. So, what we're going to speak about today. So, I will give a very, very quick introduction about the topics. Then we will speak briefly about what is WPA and WPA2 enterprise. Another very quick introduction about the basic for WPA enterprise hacking, and then what's new about this talk. Like actually, it's not something very new, but it's something that we encountered in a red teaming engagement. So I want to speak about this experience. So a quick note about red teaming. Red teaming usually has as objective not to stress every defense mechanism that is in place to protect an asset, but instead is to obtain a goal or one of these assets. So the difference from a normal assessment is that I don't care to stress all the physical security stuff, cyber security and human security. I'm only interested in getting one of the critical assets that I have as a goal. So this is just a quick introduction about a red teaming engagement. So why are we interested during a red teaming engagement on Wi-Fi and specifically enterprise Wi-Fi networks? Because usually we have hundreds, if not thousands of different users, and each user usually can choose his own password. So it's very possible to find a weak password to connect to the enterprise Wi-Fi network. We can try to reuse the credential for example, OWA access, email access, and whatever, because often the authentication in place is a sort of single sign-on, so we can use the same credential for everything inside the enterprise network. That also means that we can have direct access to the company intranet network, and that's very useful for getting the goal that we spoke before. And moreover, since most of the time we are speaking about Windows-based network, we can also launch a series of other attacks on the network that we all know, like responder and this kind of stuff. And finally, usually, enterprise Wi-Fi network also provides us internet access that is also very useful to exfiltrate the data that we are interested in. So that's what makes enterprise Wi-Fi a very interesting point of entry during a red teaming engagement. And the last thing that I forgot to put here is that we can get this kind of access remote. I mean, we don't have to get inside the facility usually. So what's the security in WPA Enterprise? So WPA Enterprise support dynamic delivery of master keys. That means that every user has his own password and therefore his own encryption key. And so even if I know the key to access the network, I cannot decrypt the traffic of other users. The authentication relies on the 802.1x authentication standard that basically gives me a framework in which I can create my own authentication methods that are the EAP methods, and that depends on the infrastructure that I want to build. Usually on open source, usually this kind of authentication is based on open source software that is FreeRadius or more recently hostapd, and this is also what we use to attack this network. We will use a patch version of this kind of software. So as I said, we have a lot of different authentication methods that we can develop using this framework here, but most of the time the idea is the following. So we have the client, we have the authenticator, and then we have the authentication server. So the authenticator never stores the keys, the secrets, or the password. So even if we have a vulnerability inside our router, we don't have direct access to the credentials of the user. Instead, standard WPA personal, the keys or the password to access the network is stored inside the router, of course, because it is the router that handles the authentication. In this case, the router only handles the communication between the client and the authentication server that usually is inside the intranet or inside the network. So we request to authenticate, then the authenticator forward our request to the Radius server, and then the Radius server send to the client, okay, to authenticate you need to use this specific method that we will see later. The client will do his stuff, like encrypting the key and all these kind of things. There is a handshake in here, and then if the password is correct and the encrypted password is correct, the radio send an acceptance packet. So there is another difference between the standard WPA and enterprise, that usually in enterprise network we also validate the certificate of the, at least of the server. So that means that when I try to connect to a new network, I have to accept the certificate that the server is presenting, and then I will use the certificate to encapsulate and encrypt my data for the authentication and the communication. So these are some of the available methods that are the most common one. Actually, the most common one is probably PEAP, that is the the standard that Windows will use, but also EAP TLS is not very common because it requires one step that is usually not very straightforward to implement, that is the certificate installed inside all the clients. So if I want the server to validate the clients also, so to avoid man-in-the-middle attacks, I also need to push my certificate to all my clients in order for them to be able to validate the server. So this is the main issue here, and that's why PEAP is the most used one at the moment. So what is PEAP? Basically, we have a password-based authentication for the device and a certificate-based authentication for the server, for the clients to verify the server. Actually, the password-based authentication can also be implemented with the certificate or smart cards nowadays, but you know, when you speak into Wi-Fi network, most of the time we only have the password because I want to be able to access also from my mobile phone, etc. As I said, it's the most popular enterprise Wi-Fi security mechanism, and again, the PEAP has its own standards, and the most used one is EAP MS-CHOP v2. Most of you already probably saw this kind of standard here because it has native support on all the Windows machine, also the old ones. And as we know, in enterprise network, there is always a Windows XP machine somewhere that needs to be connected to the network. So that's why this is still the most standard one. Okay, that was the very quick introduction about WPA Enterprise. So how can we attack WPA Enterprise Network? So basically we use, as I said, a patch version of hostapd, that basically allow me not only to to try to authenticate the client, but it also prompts me and write me the credential, the encrypted credential that the user had tried to use to connect to the network. So the idea is that, we create a fake network, probably with the same name as the real one or a similar name, and try to lure the user into connect to our network, and therefore to send with us the encrypted credential that then we need to crack. So as I said before, PEAP, but also EAP TLS use a server-side certificate. So the user have to accept the certificate that the server presents. So when I create my own fake access point, the user will get a prompt saying, wait, the certificate is changed. Do you want to accept it or not? Most of the time, the people said, okay, accept it. But sometimes there is an option. This I already spoke about. I will talk about the option later. So most of the time, the user will accept the prompt and then install the new certificate and send the credential. Okay, quick thing about MS-CHOP v2. Most of you probably already know, but okay, we'll speak about that also later. That's fine. So what do we use during a red teaming attack to get this kind of information? So In red teaming, as I said, we can do everything, right? We can go on client side, drop some I don't know, for like Raspberry Pi, and then wait. We don't have a very specific time limit, so we can attack on the night, on the day, everything. So, for example, in this case, what we use is a very simple Dropbox machine, which is basically a Raspberry Pi with some custom software and some modification of a standard Kali Linux. An external battery to let you run for like a couple of days and then forget about that. Of course, an external Wi-Fi antenna to get longer range, because when the victims try to connect, they will try to connect to the most powerful network at the time. So we want to be the most powerful network at the time. And then optional, we also use sometimes 3G or 4G dongle so that we can connect, actually the drop machine connects back to us and we can query for credential and check the status of the machine or reboot it or reset it if something goes wrong. And sometimes we also use some 3D printers to create a proper box for putting the Dropbox machine and then hide it somewhere. Like, I don't know, maybe you saw in the street is like a poison rat box that is very common. No one wants to touch it because it has poison, dead. So it's pretty convenient to store a Dropbox machine. Okay, so that's quite easy. I mean, this is common knowledge, nothing new here. But during one of our engagement, we found an issue that basically our victims didn't get the prompt for the new certificate, therefore they could not connect to our fake access point. So we started to investigate the problem, we tried to reproduce with our own devices, and we found that there is an option on Windows machines that allows the computer to automatically drop any certificate that is not in a trusted Microsoft root CA. So basically, when we generate our own certificate, of course, our certificate is self-generated, right? So it's not present in the standard trust Microsoft root CA. And therefore, the victim machine automatically drops it and doesn't even prompt the user to accept the new certificate. Therefore, no credential, therefore, we cannot access the victim hash or password. So what's the idea? The idea is to get a trusted Microsoft root CA certificate. So this is a portion of the root certificate in Microsoft Windows at the moment. This is updated like, I think yesterday or something like that. So do you know how many of you recognize this name here? No one? This is Let's Encrypt, CR. So Microsoft recently added the Let's Encrypt CR to the trusted root of the Windows machines. So that means that we can get a free certificate that we can use to authenticate to validate our certificate to the clients and therefore prompt them to accept the new certificate and enter their credential. So to wrap up the idea is to create a phishing domain, a standard phishing domain, something that is similar to the corporation we want to attack. I here used like how my company's, the website is opposingforce.it. I try to use op4.it. And then maybe a subdomain to make it more realistic, okay? Then we use certbot, that is the tool that Let's Encrypt provides us to create a new certificate for our subdomain. We save the certificate on the new machine, on our Dropbox machine, inside the host APD WP directory, full chain, and the private key. These are the two files that we need. And then we can finally get the credential from the victim. So in this way, we can bypass the option that Windows has set to validate the certificate before prompting the user. So what are we trying to do now? The idea now is to developing a small tool, a small script that automatically will get us a domain, obtain the specific certificate, valid certificate from the certbot, and set up the fake access point with such certificate. So using a host APD. In that way, we can just execute the script on the Dropbox, deploy the Dropbox, and forget about that for a couple of days, and then check for the credential. So this is the idea, and we plan to release the tool on GitHub in, I don't know, maybe a couple of weeks now. Still trying to figure out what is the best provider for domains and these kind of things. So that's my very simple talk and my opinion. One of we actually spent a couple of days to figure out what's the problem there in this kind of engagement. So maybe some of you will face the same issue, and now you have a possible answer for that. So please ask me some question, because then we have lunch and we can forget about this.
Thank you very much. Any questions from the audience? Okay, well, do keep in mind that if you do come up with any questions, he'll be around, so don't hesitate.
I'll be at lunch, like you. So very easy to find me.
Okay, so right now it's time for lunch. We'll start back up in 1 hour, so be here at 2 p.m. To catch up with the next track. For all the paying attendees, there will be lunch on the ground floor in the lobby at room Ash and Elk. So I hope to see you again in 1 hour. And give it up one more time for Matteo.
Thank you.